Well, there's really no telling what could be in here. It could be anything. So this is going to be a little bit meta. So I've been wanting to step up the audio quality on my videos while also not tangling myself up with cords or spending a bunch of money. So in my first two coaster melt videos, I recorded those using a portable recorder, the Zoom H2. And the audio wasn't great. The signal-to-noise ratio wasn't so good. I've moved since then, and I'm in a much better place for building things, but unfortunately the acoustics are not so great here. So I figured a good compromise was to get an inexpensive wireless headset mic. And so far, this does seem to be a big improvement from the omnidirectional lavalier I was using before, just because I can get the mic way closer to my face without getting in the way. Unfortunately, if you're on headphones or you're in a quiet room, you might also notice the background hiss. Today, I'm going to see if there's anything we can do about that, and at the very least, take this thing apart and see what it's like inside, and see if there's anything easy we can do to improve the quality. This came as part of a kit with a headset and a lavalier, along with the transmitter, for like $80 on Amazon. Here in the bottom, you can see the specific model number there. It says FCC tested, but doesn't actually have the FCC ID, I guess. That's interesting. It does say that it'll run off of 13 to 15 volts. It comes with a little switching power supply brick, which I tested at 13.8 volts at no load. Here's the back panel. You'll notice it also says 13 to 15 volts DC back here. Somehow that also implies a risk of electric shock. I'm not really sure how that follows, but maybe we'll find out. Just to keep this interesting, since this is much better than the previous microphone I was doing these videos with, I will be using this microphone receiver while we're taking it apart. Alright, so before we take this apart, we should really make sure we know where the source of the noise actually is. Let me show you what I've done to try to narrow down this problem. So this XLR output here is just headed right to my audio interface. And just to rule out anything on that side of the input, I can just mute that input and we can check the noise floor. So if you heard that, the noise, at least from my hearing, went away pretty much entirely. Definitely the kind of raspy electrical hiss is gone entirely with that XLR muted. If I unplug the XLR from the receiver, it's pretty quiet. There's a little bit of 60-cycle hum. Since that's a balanced microphone input, if I unplug it, I get some hum, which depends on the cable's orientation, since the cable's acting as an antenna. But if I short out the two signal wires with a small piece of wire, then that effectively grounds the input, and now I actually get a quiet signal, the same as when I use mute on the mixer. All right, just for another test, let's see what happens when we unplug the input power, just to see if that's an active source of this noise. There's definitely some noise with the power unplugged, but it's different than the noise with the power plugged in. It's more like the kind of lower frequency hum that we get when the output it just isn't being driven. To rule out another source of noise, I'm going to turn off the transmitter. And now I'm back. So that just results in a very, very tiny click. And then even with the transmitter off and the receiver not getting a carrier wave at all, you still hear pretty much the same hiss, which tells me that hiss isn't actually coming from the radio signal, most likely, but it's probably coming from either the preamplifier driving the output on this microphone receiver, or potentially it's coming from something in its internal power supply or power supply filtering. Just to rule out another externality, let's try replacing the switch mode power supply brick with a linear power supply. That might be a very slight improvement, but the bulk of that noise definitely seems to be there. Yeah, that sounds very similar. I don't think much of that noise, if any, is coming from the power supply, but we can go ahead and leave this connected to the linear supply just to keep that ruled out. So I'm giving it 13.8 volts, the same as the open circuit voltage on the wall adapter it shipped with. And pardon the broken segment on my current readout. So the next thing to check would be this volume knob at the front. It'd be nice to know whether the noise source is before or after that attenuation. So I've been recording with this at max level the entire time, and turning it down and then back up, I don't hear any change in the noise level. So whatever that is, it's after the attenuator. So at this point, I would like to get this thing open, and it is not obvious to me how to do that. It looks like the front snaps off at some stage of this, and this comes apart in two halves potentially. These look like snaps, but I think there might also be, like there's a hole right behind this risk of electric shock sticker, which is kind of silly. There's another one on that side. I don't really care about bending the label on this thing. It's supposed to sound good, not look good. Well, that first divot, I don't see a screw or an adjustment potentiometer or any of the usual things you'd expect to see in there. It looks like the edge of some kind of board-to-board connector. Yeah, and if I look in there closely, I can see what looks like a 4-pin JST wire harness to board connector back there. Maybe the front and back of this have two separate circuit boards. Either way, that does not appear to be the way in. Cover that up like nothing happened. Alright, so I think I'm going to assume the other hole on the back probably isn't much either, and that it probably just violently snaps open. Alright, got the heavy gauge pry-in screwdriver. They say in the instructions to lay the antenna at a 45-degree angle, but I really don't think it matters at this closer range. So, yeah, that definitely is a bendy one. Alright, I think that's the snaps. And of course, if this were a metal enclosure, I might hear a difference when we opened it, but being plastic, no such luck. So there's the board-to-board connector I was seeing earlier, clearly going to the front button and LCD module. There's just a little piece of wire glued to the bottom of the case here. Oh, gotcha. So this is probably like a dipole antenna where the feed is in the middle here, and then there's one end coming out along the case here, and then the other end comes out along the outside. I hadn't actually tried taking these off, but that explains why these aren't like regular SMA connectors. Neat. It's really interesting that the radio receiver, the user interface, and the kind of I/O board are all completely separate in this product. You know, I don't know whether that's because, you know, this was like bought as a module and then integrated by someone else, you know, and that has different back panel options available maybe. And it's just strange to see this board made with like single-sided and, you know, jumper wires, whereas this one's kind of a relatively nice-looking surface mount board. The front circuit board just has the LEDs and buttons. Actually, it looks like this connector wasn't actually fully seated. I guess I can seat it myself. That didn't seem to be causing any problems, and that's not the kind of thing that would cause, like, hum, probably, so. This bottom board really seems to be concerned with just inputs and outputs. You know, maybe they have other versions of this product with different outputs, or, you know, maybe something that's integrated into a rack mount unit, and they would not use this board, but maybe they would use this little board. So the bottom board here just seems to have, you know, some considerations for power input and signal output, and then this board seems to have pretty much everything else. So I looked up some of these chip numbers. This bottom board, so this one next to the power input is an LT571D, which I couldn't find any data on. Then over here, this little 8-pin chip is a UTC4558, which is a dual op amp. So that one's probably doing something related to either driving the balanced XLR output or maybe mixing in this auxiliary input, or maybe both. So we'll see. And aside from a load of these little electrolytics and one little input protection diode, there doesn't seem to be anything else on this rear board. The capacitor situation definitely seems to be quantity over quality here. They're all HY brand, which I haven't heard of. I don't know if that matters, but they have these big chunky 1000 microfarad 16 volt electrolytics, which presumably are there for filtering out power supply noise, but don't seem to be doing their job, or at least they don't seem to be helping with whatever the primary source of noise is in here. And this top board, I'm guessing, either is something that the same manufacturer might have invested a little bit more time and money into designing, or it might be a module that they buy from someone else. The model number on this board has the same format as the other board, even though they use very different manufacturing processes. So that would seem to support the theory that, you know, this isn't like a subcontracted module, but it's just something that they care more about, or, you know, needed the extra density in. This chip here, the CD2003, seems to be pretty much the guts of the radio receiver operation. This is designed as kind of a general purpose AM/FM radio receiver with all the building blocks you'd need to make something like that. It's interesting that that chip would not be under the shielding can here. Presumably the shield has all of the kind of high-frequency RF, and by the time it reaches this chip here, it's down to the intermediate frequency. Now we have a couple more of these 8-pin op amps now in surface mount. And then this is the microcontroller. Let's get a closer look at that. Is that a Hitachi Super H, maybe? Alright, after getting our bearings in this thing, I think now it's time for some experiments. This little 3-pin wire runs right from the attenuation knob up here all the way to the back. So I'm curious if the hiss persists when I unplug this cable. The hiss is a little different, maybe slightly. My microphone's muted, of course, but the bulk of the noise is coming through for sure. I think the next thing I'm going to do, and this one I will do with the power off, but I'm going to unplug the power, then unplug this ribbon cable, and actually I'm just going to yank this. The voltage regulator's on this side. What's the worst that could happen? Ah, that's great. So that was a completely different kind of hum, I guess. Alright, maybe it just did that because the high impedance inputs on this were floating. I was hoping that would tell me whether the noise was coming from this board or this board, but the fact that it just replaced that with completely different noise kind of made the test not so useful. Why are there extra bolts here? Is that just to keep the thing together? That is so weird. Oh, you know what? That's probably holding a device on the back of the board. I would not do something like this without power supply current limiting. Alright, I'm going to have to momentarily unplug just to get this out. I'll be right back. Alright, we're back. And this board is far more than meets the eye. That bolt was just the beginning. I'm going to tighten this back because it is loose and it's holding on a 7809 regulator. Oh man, and that board that looked like it was so cheap and gross. Really, it has a couple of components on the back. It's got a couple of resistors and capacitors. Transistor, maybe. That's much more than I was expecting. I mean, it's even got a solder mask. I just caught a little whiff of 60 hertz hum, and it seemed to change when I moved my hands, which is not at all unexpected. Let's get a closer look. There's some really interesting surface mount parts on here. There's the 3-pin connector for the volume control. There's the larger row connector that leads to the receiver board, and the Stealth 7809. I wonder if they split up the regulators just for heat dissipation reasons. There's a 7809 on this board, and 7805 down here on this board. Oh, you see that? We're using a 0 ohm surface mount resistor just as a jumper right there. Yeah, there's a couple of those on the board. Here's another one. Just so they don't need another layer. This was enough. Yeah. Alright, that was something I was curious about. This auxiliary input, I was curious about its impedance. I pick up some hum on it, not as much as I would expect if this was just like a really, really gained up input. That's interesting. I do still get a hum if I just ground the auxiliary input. Oh, is this an auxiliary out and not an auxiliary in? I'm trying to figure out how this XLR output is wired, first of all. So we've got the ground on the right, and then balanced audio pair here, and then these two little pairs are electrolytic caps on the other side. So this end of the balanced output isn't being driven, it looks like. It's just capacitively coupled to ground. This has got to be an auxiliary output. I mean, I don't know. I thought it seemed like it was labeled as an auxiliary input. Maybe they mean you to use it as an input, but I don't know. They just connect it like it's just paralleled with the XLR after some capacitive coupling. So, like, maybe they intend you to use that as like a mixer, kind of. That's weird. These right 3 pins seem to just be for power switching. After the input power goes through the protection diode right behind here, it ends up on this pin 3rd from the end. Then we've got one no connect, and then this pin on the end, I'm guessing is the power coming back to us through the switch, because that heads right to the input of this 7809 9-volt linear regulator. These two large devices on the inputs and outputs of this 7809 are those big 1000 microfarad caps from earlier. Either this fill over here isn't ground, or maybe they just wanted to isolate this current return path. But it's interesting, the DC minus over here kind of snakes through, and then there's a jumper. Where's that go? It jumps right there, and then that's the ground for the regulator. So they want the, I mean, maybe this is an accident, but I'm going to give them the benefit of the doubt and assume that they did this on purpose. And it's a good idea for current paths like that to have a small loop area that they enclose. So if the minus and plus for this input power supply, kind of one went over here and one went over there, then all of the area they enclose would be, effectively acting like a transformer, inducing electric fields in parts nearby. So keeping those wires close together keeps the loop area small. These pins on the left side are also power related. So we can see, just based on the connections to the 9-volt regulator, that this one must be, some kind of ground, and then this one is regulated 9 volts. Yeah, that 9-volt power rail also goes to several places over here. It looks like it's running this amplifier circuit over here. This next signal, 3rd from the left, actually just runs right over into the volume control, back to the front of the case again. This is an interesting sort of design that doesn't make a ton of sense all put together, but the individual pieces probably make a lot of sense in the context of whatever modularity they were planning on for this product line. So this audio signal here should be relatively clean. Yeah, it seems like whatever noise we're tracking down happens after that point in the circuit. I'm going to ground onto the voltage regulator tab. You can't always trust these tabs to be ground, but on the 78 series, they're ground. Wow. That's a little subtle. I don't know if you can hear it, but when I attached my scope probe to that nut, you get a tiny bit of extra 60 hertz hum. Thanks to our old friend, the ground loop. Check. There we go. There's some audio-ish. Whoa. Oh, well, it's got some hash on it. Ooh. Is that what I'm putting on it? So aside from this wonderful ground loop, that seems to be an okay signal. So I don't know why this is so complicated, or what it's trying to do. I mean, like, this interface is very simple. It's just power. I mean, it's power kind of in and out because the button's on the other board, but this is really just power and audio signal in at line level, presumably. What's the level like? Check. That's pretty low. It's probably line level-ish. All right, so the current mystery is, why does this thing even have so much circuitry on it? The other board handles all the radio reception. We do have the 9-volt linear regulator over here. This connector, aside from the power going back and forth, it just has line-level audio coming in. Then this connector goes to the variable resistor on the front panel to act as an attenuator for controlling the gain. But then, you know, we've just got that line-level audio coming over here, and let's figure out what happens to it next. Because, you know, I would really just expect, at most, you know, I mean, what I'd really like to see is a nice balanced line driver, which they could implement kind of with that dual op amp. But it doesn't seem like that's what they've done. I'm curious what this actually is doing. All right, so after the audio comes off the wiper of this potentiometer here, it looks like it's AC coupled through another big electrolytic capacitor. Then it jumps over this trace with another 0 ohm resistor. I'm still weighing whether it's worth going deep into reverse engineering this circuit. It looks like really broadly this long kind of unidentified chip is the output amplifier, and this little 8-pin guy is acting as a kind of preamplifier for the signal coming in from here. And the two things that I thought they might need active circuitry for on this board are doing a proper balanced driver for the XLR output, or mixing in this auxiliary connector, which I guess is an input or an output of some sort. Doesn't seem like the active circuitry is doing either of those necessarily, so I'm clearly missing something at this point. Wow, I thought it was just the lighting in here, but there's actually some really nasty soldering on this board. Yeah, I haven't done anything to this board. Like you would have seen me if I did this. It was like that. This is a really strange trace pattern around the unidentified, presumably amplifier chip. That's the kind of layout you would see around a really sensitive input that needed very low leakage current. Yeah, so these... that's interesting. This next pin just seems to head off to some of these unpopulated lands over here. I want to know what this little 3-pin device is for. So on the right there, we have unswitched, not unswitched, but we have unregulated switched power. That is unswitched power. Oh, I wonder if this is a soft power on switch. Not like soft power on where there's like a momentary button that you press, but like it powers on the output softly. Oh, so maybe that's a mute circuit. What am I talking about? This signal right here? The one that buzzes when I poke it? Yeah, that one. So that is the, that's the pretty much final output of this board. That goes, through a small series resistor to this aux jack, and it goes through a blocking capacitor, the pull down resistor here. Pull down resistor, and then a DC blocking capacitor. There's a big electrolytic on the other side. And that goes to the XLR output with the naughty fake balanced thing going on the other side. So that's the kind of final-ish audio. So where does it come from? And what else interacts with it? The actual signal seems to be coming in AC coupled again right there from this amplifier thing, presumably. This circuit, I suspect, is some kind of power-on related mute circuit, so that either while this is off or while this is in the process of turning on, it mutes the output by just clamping it directly to ground with a transistor here. So at this point, I don't really feel like totally reverse engineering this buffer amplifier circuit, because I'm pretty sure that it's not really necessary in this case. It seems like this board was designed to support some other products or some other features that are kind of like, stubbed out in some sense for this product. And my hunch here is that these two amplifier chips are not really doing much other than adding noise to the system. So if I wanted to spend a lot of time reverse engineering, I could make a schematic diagram for this, which would help somewhat. But I still don't have any data on the larger chip on the left that seems to actually be driving the outputs. So I don't know how much that would actually help. So at this point, I think all that's left to do is just try bypassing the amplifier and see if it sounds better. It would be nice to actually go through and measure and see where the noise is coming from, but I don't really have a good setup for doing that here. The oscilloscope is adding so much noise in through that ground loop problem that it's hard to see what else is going on. So for the moment, I think it makes sense to leave this what looks like a mute circuit in place, since it seems useful, and as far as I can tell, it doesn't seem to be adding noise, and we can always take it out later if we need to. So I think on the output side, we want to go in right around here, probably kind of displace this resistor a little bit, and solder a wire to that capacitor leg. And then on the input side, since we've already got that capacitive coupling, we can just, bump off that 0 ohm resistor just to make sure this isn't coupling noise back into the input, and then tack on a wire right there. Is this it? Please tell me this is not lead-free. This is not lead-free. Oh, fuck, it's lead-free. Alright, I'm going to start with picking up the input signal right off of that trace from the potentiometer wiper before it heads into that first AC coupling capacitor. Don't try this at home, kids. This soldering iron tip apparently is grounded with a fairly high impedance ground, so... But you never know what you're going to get. I had a soldering iron once where the tip managed to short right to 115 AC. It was not fun. I was soldering some phone line at the time, which was also a stupid thing to do. But, yeah, all the phones in the house rang, and there was a little spark at the end of the soldering iron. And it was interesting. The soldering iron doesn't sound like much, but the solder sure does. How's that? Oh, wow. The noise I'm hearing in my headphones sounds less like electronic hum and more like stuff that could actually be happening, so I'm going to try muting my microphone. Yeah, that's much better. The environmental noise is now really easy to hear, and the electronic hum is gone. Well, that might just be a simple fix. I will clean this up slightly, and then it's possible that just bypassing all of this, whatever the hell they were trying to do, is a much better option. I mean, it's possible that this is going to be less good at driving cables, but I mean, I plan on running this through maybe a foot of cable to my audio interface, so that's not really a big deal. Now I'm hearing the occasional thing interfere with the transmitter. Oh no. It's like when my headphone cable gets just right aligned with its antenna, it gets a tiny bit fuzzy. I'll probably find that screw later. By then, I won't care, or this thing will have already broken in some other way. Alright, one last thing we should try, just to make sure that the quality holds up even when this thing's running off of its usual power brick. That seems about the same. Let's try again. Yeah. Alright. Well, I'm happy with that. That's a nice budget wireless microphone that's now no longer bothering me, and I think I'm going to use this thing happily instead of slightly hate it every time I use it. So I hope you enjoyed that. I hope it also might inspire you to take apart something that isn't quite behaving right and see if you can make it better. And if you like this, maybe check out some of my other videos and subscribe. Thanks.